Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is Modern Data Platform in Oracle Cloud, where you will learn to gain control over your data with a single platform to collect, curate, and all your transactional, warehouse, analytical, and AI assets. All right, so this session is being recorded and you'll be able to find the recording on Cloud Customer Connect. You can also find the recordings and slide deck PDFs of our previous sessions there. I'm Olivia Ferda, Cloud Engineer with the Customer Enablement Team. And today I'm joined by Riz Mithani, Senior Cloud Engineering Manager, and Rajib Ghosh, Master Principal Data Architect, as the main presenters. Like always, a quick reminder to use the Q&A box down at the bottom of the screen for any questions throughout the session. With that, I'll hand it over to Riz.
Thank you, Olivia. As Olivia said, this is Riz Mithani. I'm a Senior Cloud Engineering Manager in the Data and AI team at Oracle. I've been with Oracle about 10 years and have 20 years of experience working in the middleware space. Rajib?
Yeah, I'm Rajib Ghosh, and I'm a Master Principal Data Architect in the Data Science and AI space and Data Platform space in Oracle. And I have a broad analytics background in the past, having worked with multiple industry verticals. And I'm glad to be here to help you with the data platform needs of the enterprise.
All right, so let's start with the objectives of this session. We're going to start out with discussing the Oracle Modern Data Platform and what business outcomes it can deliver. Also go into details of the architecture, which shows how it is open, unified, and complete. Majority of the time will be spent on a specific use case so that you can understand, along with a demonstration, how the Modern Data Platform and its pieces work together. And then we'll come back and also talk about the differentiation from other solutions in the marketplace, as well as what makes the data platform cost effective. So Oracle has, over a period of last 5 decades, about 400,000 customers, and they select Oracle because the solutions and services that we provide are directed towards the enterprises, and these enterprises need scalability, performance, security, as well as predictable pricing. But let's jump right into the topic here. What we mean by being able to get more out of your data is really that you should be able to derive actionable insights. And those actionable insights should come not from just part of your data, but from all of your data. Analysts like Gartner, Forrester have studied projects that use analytics and AI, and Gartner says that about only 20% of these projects really deliver positive outcomes, while Forrester's study showed that 70% of the data that you have in the enterprise is not really utilized to make those decisions. But there's some good news from McKinsey in the sense that 2/3 of the projects that infuse machine learning and AI into this analytics are deriving value. So we'll start looking at the Modern Data Platform and see how we can enable some of this value within your organization. Dara could not have said it better than I here in terms of essentially what I was saying on the logo slide there. Really, it's about getting the price points that you need for the performance that you need for your data projects, and the scalability, as well as it needs end-to-end security. The business outcomes that the data platform, Modern Data Platform delivers, we talked about generating actionable insights, and those actionable insights need to come from the predictions that you make, and the prediction need to happen in real time. The self-service analytics is really table stakes for Modern Data Platform, as well as being able to take advantage of the new data economy in the sense of monetizing your data, identifying areas of your business that can benefit from the traditional economy to more of a subscription-based model. We've seen the gains that the Modern Data Platform gives across industries. So no matter what industry you're representing today, like For example, in banking, 40% increase in marketing conversion rates, manufacturing, 50% operational cost savings, again, public sector too. I'm not going to go through all the examples in the interest of time because we want to really spend time on the architecture and the demonstration. We talked about climate sustainability earlier. So Deutsche Bank runs 10,000 of their databases with 50% less energy. So you can see, some of the different types of outcomes you can get from the modern data platform. I'm going to pass this on to Rajiv now so that he can talk about the modern data platform architecture and how all this is made possible.
Okay. So this you see in the screen is a single snapshot slide of the Oracle Modern Data Platform. The basic idea of this is it covers your enterprise data needs in totality. So as you see, there are many components over here, and the couple of items which are of importance I want to touch by is the first thing is the data sources, what we call the system of records. On your left-hand side, which you see Oracle packaged applications. On the top, you see Oracle business applications. Then there are things like any applications, IoT, social media, digital assets, big data lakes, or Hadoop. So these are kind of the enterprise data sources today, which normally enterprise interacts with, and we cover it all, right? In the middle section, what you see is after we ingest the data into the platform, what do we do with it? So it is showing you the various ways an enterprise processes data today, right? For example, like we do transaction processing, we do data warehousing, we do large data lake processing, we do kind of Spark-based sensor data, processing, which is data flow in our case. We also do Hadoop-based big data services, and also there's a need for cataloging data to get the single source of truth. I mean, all of you may be familiar with all these concepts, and the key things here is that we covered it all as part of the Oracle Data Platform, and this is showing kind of a tool agnostically what are these processes are in a short manner. And on the right-hand side, which you see that what is the outcome of that processing. So what we see is basically Oracle Analytics Cloud, Power BI, Looker, Tableau. All these tools are basically showing you or helping you to visualize the outcome of that processing of the data which you do with a goal to do a meaningful business outcome, right? So this is all part of the descriptive analytics. And as you see that the Oracle Cloud is not only has an interface for visualization with Oracle Analytics Cloud, but it is also geared to support the tools which you used in the market, have been using in the market for a long period of time, right? And not only that, we also have a full-fledged predictive data analytics interface. We call it machine learning and AI, that has got many different flavors like data science and machine learning and all the AI capabilities. And also like the modern applications development with DevOps, which is shown on the top with Kubernetes and containers and API management and low-cost epics. So no matter where you are in the enterprise data journey or what you have in the enterprise, we covered in this data platform with the guardrails of governance, security, and performance natively implemented in the cloud, and addressing the needs in a different dimension, like public cloud with multi-cloud and hybrid cloud or dedicated cloud. So all of these are kind of the need, and we offer it in 3 distinct different pillars. One is open, unified, and complete. Hope that makes sense to you.
Yes, Rajiv, but I would still like you to spend a little bit more time on describing what exactly you mean by open, unified, and complete.
Sure, that's a very good question, right? So let me tell you what it means is the 2 boxes on the right where we talked about the different sources and the application data sources. So we are open, so which means any data sources which you can think of on the planet, we can ingest the data in that particular format or that particular way to do processing. So we are open. So we're not constructed to one set of ideal guidelines or something like that. And we can also process the data, right? We ingest the open and all the open data source, and we can process it in a uniform way, which is very familiar to the people processing. We also do it in a unified manner, in the sense that this slide is kind of describing the enterprise, right? So when the enterprise comes to us, whether you are in an on-premise or in a multi-cloud environment or within the OCI itself, but you want to operate in a unified manner, that's where actually we shine, and we give you the the tools and processes to make you successful there, right? And it's complete. I mean, you name it, we have it, right? We have the business processes inside the cloud. If you want to use your own business processes in your enterprise, in other clouds, in a multi-cloud scenario, we still support it. And we always operate in a fashion of complementary fashion, with the goal that it needs to be complete. So that's our goal, and I hope that explains what you're asking, Riz.
Yes, absolutely. What I'd like from you, Rajiv, next is if you can address how the enterprise data problems that I was talking about earlier, and the analysts also talk about, how does this modern data platform really address that?
Right. So let's go to the next slide, which actually defines how do we solve it. So we talked about the architecture. So this one shows you a little bit deeper, where we talk about the different tools which you can use within OCI to solve the problem, right? So as you see, like in the middle, you have, let's for example consider database, for example. The database needs can be many different in different flavors in the enterprise. For example, if you are focused on transaction processing, you'll need autonomous transaction processing, or ATP. You're doing data warehousing. We have a tool called ADW, autonomous data warehouse. You're doing light amount of SQL, and you've already invested in MySQL kind of technologies. We already have that, and you can use that in the cloud. You're actually using database into your on-premise, don't want to move, you already can do a lift and shift with the Oracle Database Cloud Service, or any other NoSQL, or even if you want to go large, you can use the Exadata Cloud Service. So this is just an example. To scale this example to any other sides, like for example, AI services. Now today we have speech, vision, language, anomaly detection, forecasting, classification. So, and also with like things like OCI data science, for example. So if you're a low-code developer or a low-code CEO or a C-suite person who's trying to get the value of your data in a very, very quick, short amount of time, you have all the tools in the AI services. If you're a data scientist, want to deeper with models, and you want to play with the data, and you want to do the deployment, you are playing with the algorithms, we have the data science platform and Oracle machine learning interface there to take care of that. Not only to say that, we also have a multitude of tools, as you see on the left-hand side, like integration layer with different needs, satisfying the different needs, like OCI streaming, for example, batch ingestion, replication, and application integration data needs, right? Similarly, you have things like on the right-hand side, you can see that we have a whole bunch of data products and data technologies with DevOps, Service Mesh, API Gateway to get you the business outcome which you need, whether it is anomaly detection analysis, or you want real-time visibility, where you need accurate forecasts and predictions, all within the framework of a secured governance framework at different levels. Like we have data catalog, which is a governance framework at the data level, and we have the identity and access framework, which is at the cloud level to take care of that. So hope that explains the breadth of the tools which we are talking about.
Yes, Rajiv, this is beneficial insight to our listeners. I think when our other panelists here, like Chennai, Nara, Sri Vishnu, they speak to our customers, we all hear like, show me analytics that is real time and fast. They need to make decisions right now. Maybe if you can show us a demonstration that speaks to this ability, to predict the business outcomes now because our customers can't really wait.
Now, I do agree. Real time is the real buzz now. And so let me show you a kind of a demo, which will give us some sense of a flavor of what it is. And so we're going to take up something on an asset management real-time prediction with Oracle data platforms to give you a flavor of how the real-time analogy looks into our platform and how it works, right? So let's focus on kind of 3 different business questions here, where I can say that these are some of the business questions that are coming from the field. Like say, how can I manage my inventory in real time? It's one of the questions. Then it says that, well, how can I gain insight into a supplier performance in real time? And he wants to do it like, how can I do this with a very fast time to value and also to a low total cost of ownerships? So these are some of the 3 business questions coming from the field, and we're going to see that how we can actually get around to solve this problem with the Oracle Modern Data Platform, right? So to do that, let's define the first use case. So there's a business need which says that it's an integration of real-time predictions on a manufacturing unit failure for with enterprise asset management system. What it means is basically that you want to find out how you're trying to do a real-time predictions and integrate with the inventory and maintain an enterprise assets management system. And as you see that there's a lot of data which has been collected in each of the sensors in the enterprise, but we'll give you a sense of what kind of data we collect. So this is kind of a data which we collect typically from a sensor system, which shows you that, for a particular timestamp, we're collecting air temperature, rotation speed, torque, tool year, and failed from a typical manufacturing plant. And this data actually kind of forms the basis of training the, machine learning models down the line, which you would see, right? So let's have a look at how it looks on the other side of things when we start gathering these and processing the data. And one of the things over here, which you see, is that data which is coming out is being processed through a machine learning model to do the the prediction event, which is an attribute called probability of failure of that equipment, and that data what we are going to do is basically we are going to tie around with an e-business suite, which is an inventory management system maintained by Oracle, to show you the different actionable insights from that, which is displayable in a dashboard. Typically, in this case, it's the Oracle Analytics Cloud. And then we'll decide from that analytics interface, based on the feedback, what actionable insights which you can gauge, which can be taken by a C-suite person or any operational manager in the field to see how we can mitigate that problem or solve that problem. So, so let's go to the next section, how we can do it. As you see, pretty much what you're seeing it here is kind of a demo flow architecture. Now this architecture, as you see, this has got multiple different sections. And as you see that these different sections are like, it covers a wide range of Oracle tools, from streaming to, data processing through Spark, through batch ingestion and processing, integration with the EAM, and then also data science and data catalog, and then also putting the output through an analytics visualization interface. So for this, what we would do first is basically we'll try to attack it from the left-hand side, which is, as you can see, it is the data science and the data catalog pieces of it. And then we'll go through the different interfaces like the streaming and the batch ingestion and EM integration to complete this whole architecture to give you a sense of the data platform, how it looks like, right? So let's talk about this different data science and, kind of how it looks like. The first thing, what a data scientist kind of looks at, it's when it when it starts its project is the data catalog. So the data catalog is essentially the central piece within our lake house, which actually does the, which actually stores the metadata of all the data elements in the whole enterprise. Now, the data catalog acts as a single source of truth so that the data scientists can find out really what features are of importance and is there a clear definitions of these features which is trying to, develop models on is important and it's being is documented. So we'll give a sense of how this data catalog looks like in this demo. And one of the things what data catalog is very good in is it can harvest and it can enrich and it can also do a search. So these are the three pillars it depends on. It can harvest from a different large number of sources, whether it is on-premise or on cloud or anywhere else in a multi-cloud, so that the main objective is to have a single catalog. And in main objectives also you will be having the ability to enrich that data so that you can make some meaningful customizations to the metadata which you have harvested. So this kind of shows you the different screens which you would typically go through. And it's a very, it's a workflow-oriented tool, and you can actually get all this harvested data and get into the catalog. So next thing, which as I mentioned, that the data scientist what we will go through. So let me give you an example of a short demo of the data science environment. So what you see basically over here, it's a data science environment which is project based again, and it's also Jupyter Hub based. I mean, the core architecture is based on Jupyter Hub, and it enables you something called a notebook session, which you see it on the screen. And those notebook sessions are nothing but a fully fledged, managed data science environment within a VM. And it allows you to do not only just the notebooks, but also do, some kind of a monitoring, log monitoring, and all of those sort. One of the good features of any data scientist which look for is basically able to scale their environment, and which is shown out here. We offer different kinds of compute shapes, whether it is AMD or Intel or any of those, and we have offered flexible shapes as well as fixed shapes of various kinds, and that's how we give you the ability when you're trying to scale to data science environment, you have the option to do so. So this shows you a kind of a nice picture of very familiar Jupyter Notebook kind of environment. So you can do all your model work, data explanatory work, data ingestion and validation work over here, typical notebook scenario on an ad hoc basis to make sure whatever models you're trying to develop is appropriate. This screen shows you once your model is developed, you have the option of deploying it into the data science environment. And the way you deploy it is that you may be iterating over various models and to find out what model is accurate and which model is appropriate for your needs. So unless you deploy and test it out, there is no way. So this gives you a integrated model catalog and deployment interface where you would be able to deploy inside the data science environment to see and pick out the best deployment which you would be working. So this also gives you something called an API-based interface, and that can be deployed into a container-based environment, which we are going to cover up in this particular section, where you see that the ML model API endpoint that's been deployed to the functions. So let's talk about that second section, which is number 2, the OCI streaming, and then we'll come to these functions in the next subsequent minutes, right? So as you see, the manufacturing events are being ingested with OCI streaming. So OCI streaming is basically a serverless Apache Kafka compatible and streaming platform. And it is tightly integrated with a lot of OCI tools in the cloud, Golden Gate and Integration Cloud. It's got strong features like it is it is deployable. It is, it's got a simple pricing model. And what you can see is also it is elastic and scalable, and it can deploy streaming apps at scale, and it's got all the integration along with all the other tools which we described in the data platform as well. So coming to that, again, as I mentioned, that it also has something like, as you're streaming, you're able to look at the different logs, and you're able to see what kind of performance it is having, and things like it has the interface. And the second thing which we're going to talk about, that once you stream the data, we come to the next section where you ingest the data into something called a service connector hub for processing the events. So this is basically like an event-based action. So as you're observing the data, you have some specifying events, and you want to do some kind of a processing, and that some kind of a machine learning process per se, which is deployed. So that deployed model will probably work deployed as a function, but it'll work on the stream of data. So this shows you the interface where you can define the function, which is as a wrapper on top of that streaming interface, and shows you that any models which you have created can be deployed as a function with some simple steps, which will be coming over here, and we'll show you show you the steps which is needed for kind of deploying the function. So let me show you. So this shows you the interface for deploying a function. It is very easy to do it. It follows the open source function deployments, but it is already pre-populated for you in the console itself, and then it can deploy. But the key steps which I wanted to describe here in this architecture is basically it receives data from a streaming service interface. That data is being fed into a pre-built ML API, which I just described. The ML API actually deploys a function, scores on the streaming data, and that score is being outputted into an object store bucket, and which we call the raw zone, or the raw, in terms of a data flow kind of an architecture, it's called the raw zone. But subsequently, it is being taken out by our tool called data flow, which is a Spark-based ingestion engine, a Spark-based processing engine. The purpose of that tool is to basically get that output, streaming output, batch it up, and kind of aggregate so that it can produce some meaningful output in there. So let's talk about the data flow here. So the data flow is basically, it's a Spark's based ETL engine, which actually does continuous produce. It can run on ETL and continuously produce streaming data, and it has easier cluster management, simplified cluster, capacity planning, not to mention lower cost. But actually, the most key benefit of it is that it takes the infrastructure out from a data flow job, so that you can actually focus more on the code and the logic instead of the infrastructure. So that's kind of the primary use case where you can use the data flow for aggregating your data from a streaming interface. You can also do the aggregation from any other kind of interfaces, in any other form of data also. But the main advantage what you get is in a Spark-based memory-centric environment where the ETLs are run faster. Now it can be done on two different kinds of flavors, which I'm going to briefly illustrate. One is through this console, which you see over here. And what it shows is basically that you write some PySpark-based code, you just deploy it onto the OCI console, and as an archive, and then the data flow, you just invoke the data flow jobs from the console. It can read it through your archive, processes all the DDL, performs the necessary aggregation, whatever it needs to happen, and then kind of go there, right? It has a different flavor of different shapes to choose from in the deployment, as you see, and the second option which we wanted to do is that sometimes you need to do it in an interactive fashion, and that's where our data science and data flow integration comes in. So this shows you there are different ways of doing it through the data science and then data flow integration environment. And to get the advantages of your exploratory data analysis along with the data flow ETL or aggregation in a unified environment, right? So this shows you a template from a Jupyter notebook where you can start running your data flow jobs right from here. You can drive it straight from here from the exploratory in an exploratory fashion here notebook. And also we have another option called this magic commands. So if you're familiar with this magic commands, these are basically commands which help you to run the cloud-based data flow from a notebook session as you're progressing with your data science kind of session or a notebook environment. So this is a quick way of doing exploratory Spark-based analysis from the notebook itself. So give you both the flavors from a developer perspective and also from an operational perspective, right? So let's come to the one which is EAM integration. This is our asset-based integration with the data science environment, actually with the overall data platform-based environment. The objective here is to find out how your predictive and analytics lie in unison with the inventory which is being maintained into the procurement data. So that logic is actually performed by ingesting data from both the data flow and also from the EAM environment. And this kind of shows you like how an enterprise asset management data model can be tweaked to merge and mash the data's the predictive outputs to make meaningful outcomes. And one of the things is that comes out of that exercise when you start managing merging the predictive outcomes from your data science environment is this screen, which is pre-built and it is customizable in the asset management interface. And this shows you how a plant manager can take advantage or customize that interface to take advantage of the data, the predictive output data from a data science environment in a asset management system to make meaningful decisions on scheduling jobs. So these are all possible within that, the customized interface. And this is kind of one of the Oracle differentiators when you kind of integrate the data platform with the Oracle SaaS products, right? This shows another way of integrating with the Oracle Data Integrator tool, which is being used to manage and transform various data sources. In this layer, as you see, the asset inventory and autonomous data warehouse. And the final thing is that when you're done with the mashup of the data and you're in a form to share it with the analyst or the decision makers, we have the Oracle Analytics Clouds. So this is an example of Oracle Analytics Cloud interface where we have actually worked on 72 assets in the organization. As you see that the assets are kind of uniformly distributed by geography, but one of the the manufacturers like Acme Industrial, which was taken recently, has some problems with it. And so this we are doing an end of life analysis by location and end of life analysis by manufacturer. And as you see in this graph, like towards the end of the life of an asset in 3 months, usually it is about 1 year, but in 3 months, as you're seeing that the Acme Industrial data is showing some problems, right? And it is depicted in the table below also that there is some probability of failure, and the schedule end of line is shrinking. The probability of failure is being high. So these are some of the interface. So as you start drilling down, what is causing the probability of failure to be high for certain assets? This you can drill down in the OAC interface, to see the various features which is attributing to that failure. And you can actually drill down to find out like which manufacturer and is processing better in terms of those features. And this shows you also like, in a tabular format, where in which locations are being affected and which locations not. further drilling down, if you have spotted the asset IDs or the particular assets from that, from the interface, you can start drilling down more to find out, like the asset which has declined in the last 30 days in terms of tool wear, rotational speed, probability of failure, and asset ID. And this way you can identify the actual asset which is going to fail in the near term and the manufacturer associated with that particular asset. So this is a very good insight. And as you see, the real benefit actually comes from, which I'm going to show it in the next screen, is like, how it associates with the inventory in your EAM system. So as you see that, in the previous slides, that as your failure chances are increasing, but your inventory is having much lesser amount, so that's a real problem. So this is an insight. So, and plant manager can take to action to increase the level of inventory, but as well as also inform the procurement department that you might have to look into that manufacturer who's not supplying quality parts. So I hope this demo actually illustrates the features of the data platform which we described earlier. And I hope this is useful to you. And but one of the things which we typically get from our customers is, how does Oracle, differentiates in the marketplace? So with that, I'm going to give it back to Riz, who'll talk about that.
Your demonstration did go through many features that showed how the different services that form the modern data platform work together, right? But it's not all about just product features. To be successful, the platform needs to enable all the pillars of your data strategy. So let's start with security here. Security cannot be an afterthought. OCI, which is Oracle Cloud Infrastructure, is built from the ground up with the security-first approach. And that's what allows you to provide the governance as well as the enhanced data loss prevention that is needed. Moving up into the data strategy, if the data quality, for example, is unknown, then in spite of having the data, the users will not be confident in using to make any mission critical decisions. So Oracle provides solutions like enterprise data quality that would address this as an example. Again, you have further challenges in terms of where does the data reside, what's the right business metadata, and who are the right groups that own this data. And there are solutions like Oracle Data Catalog, which are going to allow you to accomplish this. And in terms of the detailed architecture itself, Rajiv has gone into quite a bit of detail, both when he was talking the architecture and all the services that form it, and then also the going to the demonstration. But lastly, I also want to talk about data sharing, which is the ability to share the data across data repositories. And that you should be able to do without having to physically copy the data. As well, you should be able to share the data with everyone within the enterprise as well as outside, with your business partners, with vendors and customers, and without requiring them to be on the same technology. So that's what you want to look at when you're evaluating data platforms, not just the product features, but also if it is going to enable all pillars of the data strategy or not. In terms of the further differentiation here, Oracle is cloud is global. The 44 regions around the world, and we're counting. It's a multi-cloud strategy in the sense that we also have 11 Azure interconnect regions, for example. I want to talk about the different deployment modes, models that we have in terms of the differentiation. So you have a choice of deployment models, especially when you're going to have stringent data sovereignty requirements. Besides the public cloud, that is subscription-based and Oracle managed, you also have choice to deploy on-premise in your own data center where you purchase as well as manage it yourself. You can also have the best of both worlds, which is the cloud customer model, where it's subscription based, and either Oracle can manage that or it can be co-managed. And then last but not the least, there is the run anywhere in terms of being able to run on disconnected edge devices also. So the choice of platforms, the choice of deployment models in the data platform is a differentiator for Oracle, and you should be looking at that when you're evaluating different vendors.
And that's a very good thing, Riz, where you talked about differentiation. But a lot of questions I get is in terms of cost, right? How does Oracle saves cost, both in short and long run? Can you discuss about that?
Definitely. Consider the three major cloud vendors that are there besides Oracle, being AWS, Azure, and GCP. And when you start looking at that, OCI has the lowest cost of pricing across the stack. It's probably not too much difference, maybe in the compute instances, 2x, and maybe even if you look at something like object storage, Oracle is a little bit more expensive. But once you start looking at block storage, where the majority of the cost comes from, or also the internet data egress costs, now you're starting to talk about orders of magnitude difference. And that's where the differentiation comes from in terms of once you deploying data platforms in the different clouds that you have choice for. The lowest data egress is important, right? It's you often see 80 to 90% of cost savings from this. This is based on the combination of providing the first 10 terabytes of free, as well as you're charging extremely low prices thereafter. It's consistent. It is the same price, and as you can see, it's order of magnitude different from the other cloud vendors, and it's same all the way up to even if you're going up to 150 terabytes of figures. And finally, also we don't charge for inter-region data transfer. And finally, Oracle does not also charge for data transfer over dedicated lines. So combination of all this definitely gives you a price point where you can start deploying the Oracle data platform. Let's take an example. Bringing the big data platform workloads to OCI and then modernizing them. We have no lock-in, low egress costs. What you start seeing is the differentiation here in terms of Oracle Big Data Service compared to other clouds. Azure is almost double. Some customer examples here of what gains Experian and MindSense were able to get with the modern data platform. So let me talk about some more customers here. FedEx uses Oracle for self-service analytics for over 3,000 employees. There's Lyft, which has consolidated 30 financial and operational systems into a single source of truth. We also have Siemens, which were able to reduce their costs by 90% and were able to get in 2 weeks, essentially, from their on-premise deployment to Oracle Cloud.
So as you see that what Riz was talking about, it's just not only the cost, but also we have customer references who have saved significant amount of in terms of percent on various pillars. So we have a good coverage on various aspects, both in terms of the architecture, performance, cost aspects, and the customer references.
All right. So hopefully, with a quick presentation, in about 45 minutes or so, where we went through what business outcomes the Oracle Modern Data Platform provides, being able to derive action and insights in real time. Rajiv also spent quite a bit of time on how it's open, unified, and complete, where you can embrace pretty much any open source as well as multi-cloud implementations. Does provide an ideal combination of price points, the performance and scalability that you need, built from ground up with end-to-end security in mind. And last but not the least, it's not just about the product features like I was talking about, but you should be able to enable all pillars of your enterprise data strategy. We also have some resources here, and you'll be getting this slide deck, but we can open this up for Q&A. I think we've been answering the questions as they come along, but if there are other questions, we can take them live.
Yeah, there were two questions actually. I mean, Vishnu answered one, but essentially they wanted you to see if you can expand a bit more on the application integration using OIC. And there was another question which was like, is OIC just an orchestration framework, or does it have tools to actually integrate?
But Nara, you're the best person to answer that question.
So Rajiv has already answered yes, like it has got multiple adapters and multiple tools. That's part of the Oracle in OIC environment, and it kind of complements that framework, and it kind of has tools to integrate from multiple sources and targets, right? We can share some links and stuff for that, because there's a lot of sources and targets, and there are a couple of other specific we would say services which offer the integration across the platform.
So I would add to that, right? In terms of how you get the data out of your source systems, right? Oracle provides multiple ways to do that, depending on what you are trying to achieve, right? If you're trying to replicate data, then there is Golden Gate, which allows you to replicate data from your source databases into a data warehouse kind of environment, or even into object storage. Then you have OCI data integration, which is the traditional ETL type of or ELT type of approach to get the data out. There's also support for streaming with OCI streaming with Kafka-based sources. And then the question was about OIC, and that really depends on if your source systems are going to have REST-based APIs that can be accessed, and will you be do they support the speed at which you need that, right? In terms of the amount of data that you can pull in. Once the amount of data starts becoming very huge that you're going to pull in from a single REST API call, then that probably doesn't become viable, and you may want to start looking at other approaches to do that. So there are various approaches, and depending on the situation and your source and target systems, you can decide what you want to use.
And one thing I would add to it for everyone's benefit, the OIC has the largest number of adapters. You name it, any kind of data sources, you should be able to get the ingested data into there. So that's kind of its strength there.
And to add to what Riz was saying about Golden Gate, we also have something called managed replication, managed service, and it is not just Oracle to Oracle. It supports multiple clouds also, and different endpoints, big data endpoints, non-Oracle sources and targets. So there is a ton of stuff out there which we can share.
Right.
Any other questions?
So I think there was a question about the multi-cloud that we were talking about, and what exactly does that support in terms of analytics? Maybe Chennai, maybe you can answer that.
Yeah, I can take a step. So with a multi-cloud data analytics solution, Oracle enables your organizations, right, to effectively run your analytics using data warehouse, which is part of our Oracle modern data platform with multiple data sources. So your sources can be right on-prem, such as Microsoft SQL Server, or it can be on another cloud. It could be Azure, it could be Google Analytics, Salesforce, eBay. But in a nutshell, we have the open connectivity. Most of the sources, most of the different clouds and on-prem sources are supported to report your data on Oracle Analytics.
Okay. Thank you, Chennai. Maybe I will expand that a little bit. Question to Rajiv here, saying, as our enterprises are deploying to multiple clouds, if you have a combination of, say, on-premise and other third-party clouds like AWS and Azure clouds, then how would the modern data platform fit in?
Yes, that's a very good question. It's actually a part of our multi-cloud strategy to help the enterprise be successful on that. And a couple of areas out there, like suppose you have, we also have something called a direct interconnect set up with Azure Cloud, so which gives us the ability that if you are using Oracle databases or Oracle ERP, EAM kind of applications, but you have invested in the Azure Cloud, and you want to run both in the scenario, we have that interconnect to help you out in terms of performance and getting the data out wherever it needs to be. And the other pieces which we see is that if you have invested heavily on the Oracle SaaS application, ERP application, then it makes sense to use all the Oracle tools, which is available in the cloud in different forms. The reason being that your processing tools needs to be close to the data. And this is an exercise we regularly perform when we are trying to evaluate your multi-cloud implementation, whether it is AWS or Azure, and in Oracle to give you a sense that you're processing the data in the right way. And that's actually part of our, kind of our white glove support to evaluate the whole enterprise and give you the right tools and right framework to make your business outcome successful, right? The third thing is that, we also, we have these, cataloging solutions, right? Now, the thing is that you may be having an enterprise spread out across many different clouds, maybe on-premise, maybe you are not there yet on the cloud, you're trying to do it, but you can still leverage a free platform called Data Catalog to source all the metadata into a single place, and you don't have to pay anything for it, like expensive tool like Colibra or Elation in the market, but you can do all of it inside the cloud and slowly start migrating into the cloud, whatever in a multi-cloud scenario, wherever it may be, to to get the benefit of this. So you can search your data sources, data elements, whatever, and that's a good example of what I initially described about how a data scientist kind of looks first only into the source of truth. So that's another advantage of starting with the multi-cloud based implementation. Yeah.
So, thank you, Rajiv. I think there are no more questions now, and we are pretty much coming towards the end of our time here. So I'll hand this back to Olivia.
Awesome session. Thank you, Riz and Rajiv. Really appreciate your time and help with this session. I hope it was a good learning experience for everyone. Our next session will be on August 15th. This session covers the key concepts, techniques, and best practices for designing a highly available disaster recovery solution in OCI. We begin with exploring the high available features such as availability domains, fault domains, load balancers, and how to use these features to build a highly available solution, followed by learning to check the status of your services. You will also learn about disaster recovery features like Oracle Data Guard, backup and restore, cloning, replicas, cross-region backups, and integration with other platforms. Thanks everyone for joining, and we hope to see you next time.